When encountering a hard, cement-like material on walls, especially in older homes, it's likely a fire-resistant material used for fireproofing. Several possibilities exist, including Celotex, Firecrete, and vermiculite. Celotex is a type of hard insulation used in the mid-20th century for fireproofing. Firecrete is a concrete-like material specifically designed for fire protection. Vermiculite is a mineral used to create fire-resistant insulation. Working with these materials presents unique challenges. When it comes to cutting switch boxes, it's best to avoid cutting into the material if possible, as it can create dust and potentially weaken the firewall. A good alternative is to consider using surface-mounted electrical boxes. These can be attached directly to the surface of the material without requiring any major cuts. When running a home wire across the firewall material, several options are available. Firstly, you can drill through the material. Use a masonry drill bit to carefully drill a hole through the material. Ensure you select the appropriate size drill bit for the wire or conduit you plan to run. Secondly, you can cut a channel. Employ a rotary hammer or an angle grinder equipped with a diamond blade to create a shallow channel in the material. This channel will house the wire. Be careful not to cut too deep, as you want to maintain the integrity of the firewall. Thirdly, consider running conduit. Install electrical conduit to protect the wire from potential damage within the firewall material. This is especially important if the wire will be exposed or subject to physical stress. Regardless of the method you choose, it's crucial to address fire stopping. If you make any holes or cuts in the firewall material, ensure they are properly fire stopped with approved materials. Fire stopping helps maintain the fire resistance of the wall by sealing any gaps or openings. Always consult with a local electrician or building inspector to ensure compliance with all applicable fire safety regulations. These regulations are in place to protect the occupants of the building and must be adhered to. When working with these materials, prioritize dust protection. Wear safety glasses, a respirator, and gloves to minimize exposure to dust. These materials may contain harmful substances, and it's essential to take precautions to protect your health. When it comes to installing electrical components in firewalls, it's often best to consult with a licensed electrician specializing in firewalls. They have the expertise and knowledge to ensure the job is done safely and correctly. Always use proper tools and techniques to avoid damage to the firewall material. This helps maintain its structural integrity and fire resistance. Above all, prioritize fire safety. Ensure the integrity of the firewall and use approved fire-stopping methods. This is essential to protect the occupants of the building in the event of a fire. When drilling, start with a pilot hole. This will help guide the larger drill bit and prevent it from wandering. Use a slow and steady drilling speed to avoid overheating the drill bit and damaging the material. When cutting a channel, use a vacuum to remove dust and debris as you work. This will help improve visibility and prevent the dust from spreading. When installing conduit, use appropriate fittings and connectors to ensure a secure and watertight connection. This will protect the wires from moisture and damage. When fire stopping, use a fire-rated sealant or caulk to seal any gaps or openings. This will help prevent the spread of fire and smoke. Always follow the manufacturer's instructions when using fire-stopping materials. When working with older homes, it's important to be aware of potential hazards such as asbestos. If you suspect that the firewall material contains asbestos, contact a qualified professional for testing and removal. Always obtain the necessary permits before starting any electrical work. This will ensure that the work is done in compliance with local codes and regulations. When selecting materials for electrical work, choose products that are listed and labeled by a recognized testing laboratory. This indicates that the products have been tested and meet safety standards. Regularly inspect the electrical system to ensure that it is in good working condition. This includes checking for damaged wires, loose connections, and overloaded circuits. If you notice any problems, contact a qualified electrician for repairs. Consider installing arc fault circuit interrupters, abbreviated of size, to protect against electrical fires. These devices can detect dangerous arc faults and shut off the power before a fire can start. Also, Install ground fault circuit interrupters, abbreviated GFCIs, in areas where there is a risk of electric shock, such as bathrooms and kitchens. These devices can detect ground faults and shut off the power before a shock can occur. Make sure smoke detectors are installed in every bedroom and on every level of the home. Test the smoke detectors regularly to ensure that they are working properly. Plan an escape route in case of a fire. Practice the escape route with your family so that everyone knows what to do in an emergency. Store flammable materials in a safe place away from heat sources. This includes gasoline, propane, and other flammable liquids. Keep the area around the electrical panel clear of obstructions. This will allow easy access to the panel in case of an emergency. Do not overload electrical outlets or circuits. This can cause the wires to overheat and potentially start a fire. Use extension cords sparingly and never run them under rugs or furniture. This can damage the cords and create a fire hazard. If you are unsure about any aspect of electrical safety, contact a qualified electrician for assistance. Electricity can be dangerous, and it's always best to err on the side of caution. Never work on electrical equipment while it is energized. Always turn off the power at the breaker box before starting any work. Use insulated tools when working on electrical equipment. This will help protect you from electric shock. Wear appropriate personal protective equipment, abbreviated PPE, such as safety glasses, gloves, and a respirator, when working with electrical materials. Be aware of the potential hazards of working with electricity and take steps to protect yourself. If you are not comfortable working with electricity, hire a qualified electrician to do the work. It is always better to be safe than sorry when it comes to electricity. Before drilling, carefully inspect the wall for any hidden wires or pipes. Use a stud finder to locate studs and avoid drilling into them. When drilling through the firewall material, use a drill bit that is specifically designed for masonry. Apply firm, even pressure to the drill and avoid forcing it. If the drill bit gets stuck, stop drilling and try a different angle. After drilling, clean up any dust or debris. Wear a respirator to avoid inhaling dust particles. When cutting a channel, use a rotary hammer or an angle grinder with a diamond blade. Wear safety glasses and a respirator to protect yourself from flying debris. Cut the channel slowly and carefully, avoiding cutting too deep. After cutting the channel, clean up any dust or debris. When installing conduit, use the appropriate size conduit for the wires you are running. Secure the conduit to the wall using appropriate fasteners. Make sure the conduit is properly grounded. When fire stopping, use a fire-rated sealant or caulk that is specifically designed for firewalls. Apply the sealant or caulk generously to all gaps and openings. Follow the manufacturer's instructions for applying the fire-stopping material. Allow the fire-stopping material to dry completely before proceeding with any further work. Contact a qualified electrician if you have any questions or concerns about fire stopping. The National Electrical Code, abbreviated NEC, is a set of standards for electrical wiring and equipment. The NEC is updated every 3 years. Check with your local building department to see which version of the NEC is in effect. Article 300.4 of the NEC covers protection against physical damage. This article requires that electrical wiring and equipment be protected from physical damage. Article 310 of the NEC covers conductors for general wiring. This article specifies the types of conductors that are permitted for use in different applications. Article 314 of the NEC covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and manholes. This article specifies the requirements for installing these components. Article 330 of the NEC covers metal-clad cable, abbreviated MC cable. This article specifies the requirements for using MC cable in different applications. Article 334 of the NEC covers non-metallic sheathed cable, abbreviated NM cable. This article specifies the requirements for using NM cable in different applications. Article 344 of the NEC covers rigid metal conduit, abbreviated RMC. This article specifies the requirements for using RMC in different applications. Article 348 of the NEC covers intermediate metal conduit, abbreviated IMC. This article specifies the requirements for using IMC in different applications. Article 352 of the NEC covers rigid polyvinyl chloride conduit, abbreviated PVC conduit. This article specifies the requirements for using PVC conduit in different applications. Article 358 of the NEC covers electrical metallic tubing, abbreviated EMT. This article specifies the requirements for using EMT in different applications. Table 310.15b16 of the NEC provides ampacity ratings for conductors. This table lists the maximum amount of current that a conductor can carry safely. When selecting conductors for electrical wiring, it is important to consider the ampacity rating of the conductors. The ampacity rating should be high enough to handle the expected load. Overloading conductors can cause them to overheat and potentially start a fire. The size of the conductors used for electrical wiring is determined by the ampacity rating. The larger the ampacity rating, the larger the conductor size. The NEC specifies the minimum conductor size that is permitted for different applications. When selecting conductors, it is important to choose the correct size for the application. Using conductors that are too small can be dangerous. The type of insulation used on conductors is also important. The insulation should be suitable for the environment in which the conductors will be installed. Some types of insulation are more resistant to heat, moisture, and chemicals than others. The NEC specifies the types of insulation that are permitted for use in different applications. When selecting conductors, it is important to choose the correct type of insulation for the application. The color of the insulation on conductors is used to identify the purpose of the conductors. The NEC specifies the colors that are used for different types of conductors. For example, black and red wires are typically used for hot conductors, white wires are typically used for neutral conductors, and green wires are typically used for grounding conductors. When wiring electrical circuits, it is important to follow the color code. This will help to ensure that the circuits are wired correctly and safely. Grounding is an important safety feature in electrical systems. Grounding provides a path for fault current to flow back to the source, which can help to prevent electric shock. The NEC requires that all electrical systems be properly grounded. Grounding electrodes are used to connect the electrical system to the earth. There are several different types of grounding electrodes, including ground rods, ground plates, and metal water pipes. The NEC specifies the requirements for installing grounding electrodes. Grounding conductors are used to connect the electrical equipment to the grounding electrode. The NEC specifies the size and type of grounding conductors that are permitted for use in different applications. Bonding is the process of connecting together all of the metal parts of an electrical system. Bonding helps to create a low impedance path for fault current to flow back to the source, which can help to prevent electric shock. The NEC requires that all metal parts of an electrical system be properly bonded. Bonding jumpers are used to connect together the metal parts of an electrical system. The NEC specifies the size and type of bonding jumpers that are permitted for use in different applications. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to trip or blow when the current in a circuit exceeds a safe level. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device should be matched to the ampacity of the circuit conductors. Using an overcurrent protection device that is too large can be dangerous, as it may not trip or blow quickly enough to protect the circuit from damage. Arc fault circuit interrupters, abbreviated as SIs, are a type of overcurrent protection device that is designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. SIs are required in many locations in the home, such as bedrooms and living rooms. Ground fault circuit interrupters, abbreviated GFCIs, are a type of overcurrent protection device that is designed to protect against ground faults. Ground faults occur when electricity leaks from a circuit to ground. GFCIs are required in many locations where there is a risk of electric shock, such as bathrooms and kitchens. Surge protectors are devices that are designed to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy electrical equipment. Surge protectors are often used to protect sensitive electronic equipment, such as computers and televisions. Smoke detectors are devices that are designed to detect smoke and sound an alarm. Smoke detectors are required in every bedroom and on every level of the home. Smoke detectors should be tested regularly to ensure that they are working properly. Carbon monoxide detectors are devices that are designed to detect carbon monoxide, a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed in every home that has a fuel-burning appliance, such as a furnace or water heater. Carbon monoxide detectors should be tested regularly to ensure that they are working properly. Electrical safety is important. Always follow safe electrical practices when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work.